Yes, today we are going to discuss about electromagnetism for the exam point of view. Just pay attention, within 15 minutes you are going to get the total concept of the lesson and what are the important for the examination you can get it. Very simple. Look at this, very easy. Look at electromagnetism mainly divided into two parts. First part mainly about Oersted experiments. Yes, Oersted experiments. Before that, generally they are asking questions based on magnetic force lines. If you take a magnet, so these are called force lines, you know already. These force lines starts from North Pole end at South Pole. This is very important point you should remember. Inside they are moving south to north. So magnetic force line is a closed loop. Outside they are moving north to south, inside south to north. It is a closed loop. So they are asking in exam, is magnetic force lines is closed loop? Yes, it is a closed loop. Based on this one we can explain. And the next step. No two magnetic force lines intersect at any point in the magnetic field. This is the magnetic field. So no two magnetic force lines intersect. Why? If intersect, it should have two directions. But basically magnet has only single direction. Magnetic force line. That is north to south. So that's why they never intersect. Number two, about flux. It is very easy. Flux. How many number of force lines present in unit area? For example, if I take this is the area, how many lines are there? Two lines. That is called flux. Flux is the number. Flux is the number just 2 Webers. Weber is the unit for the flux. Next, flux density they are asking, very important here. Flux density is denoted by B, capital B. It is also called as magnetic field. Yes, B is equals to formula pi by A. We can write B is equals to pi by A cos theta. Very important. Pi, flux is equals to BA cos theta. BA cos theta. So this units mainly, you know already, this is Weber by this is meter square. This is equals to Tesla. So Weber by meter square is Tesla. Tesla is the unit for the magnetic flux. Okay, when it is magnetic flux is maximum, when it is minimum, they may ask. So it is very easy. If the cos theta is 0, theta equal to 0, then cos theta equal to 1, then that value is maximum. When it is possible. Here is, this is a flux B. It is a flux B. This is the area I am taking, this is the area. The normal line is there, like this is the normal line. So the angle between normal line to flux is 0 because parallel line the theta equals 0. Then cos 0 is equals to 1. Then automatically flux pi is equals to BA cos 0. Therefore pi is equals to BA. It is a maximum. When maximum, if area is perpendicular like this is the perpendicular. This is a perpendicular. So then flux is maximum. If area is parallel, that means if area is like this, the normal line is like this. Normal line to flux, the angle is 90 degrees. When it is 90 degrees, it's 0, total will be 0. No flux. So from this they may ask this question. Remember. Next, yes, Einstein experiments. These are very important in the chapter. Einstein told very important sentence, that is, every current carrying conductor can produce magnetic field around it. Based on this, we have 3 experiments. Number 1 is, just you have to take the copper wire on a thermocol sheet with the sticks and take compass and keep under the copper wire. When you switch on, this compass needle will deflect. So we can understand why compass needle deflected, because compass needle is a magnet. So around copper wire, when current passes, magnetic field form. Due to that magnetic field, it can deflect. This is a simple experiment. Go on reading. Very, very important. Now the second experiment. If the straight current carrying conductor can produce magnetic field around it in a circular path, we have to show that a current carrying conductor, when it is straight line, so that magnetic field is in circle. Yes, we can show. Just you know the apparatus already. Just we have to take the wooden plank and some compasses, 6 to 9 compasses, retard stand, battery. Yes, very simple activity. Just if you switch on the current passes through the copper wire. You should keep the compasses around the hole, then observe the deflection of the compass needles. All the compass needles can arrange themselves to the tangent of a circle like this. For example, this is a circle. If you take this is one compass needle, one compass, other compass, other compass, other compass, other compass. So these are compass needles arrangement around the copper wire. So we can understand the magnetic force line is a circular path. But in which direction the magnetic field will form? Because magnetic field line has direction, north to south, outside, inside, south to north. Yes, how can we know? By Ampere right hand rule. This is called thumb rule, right hand grip rule. Even Maxwell rule also is there, but no need. Ampere right hand rule we can discuss now. Yes, take your right hand. With your right hand, if you take one conductor, like this conductor I am taking, this thumb shows the current direction, remaining finger shows the magnetic field direction. You can estimate now. When current is going upward, magnetic field is in magnetic field. When current is going upward, magnetic field is in anti-clockwise direction. See, like this. When current is coming to down, then magnetic field's line is clockwise direction. When it is coming to down, it is clockwise. When going to up, anti-clockwise. This direction given by Ampere. Vice versa. If the magnetic field, next experiment. Well, current is in straight line, magnetic field is circle. But if current is in circle, this is called solenoid. If current is in circle, magnetic field is in straight, looking like a bar magnet. It can. This solenoid experiment is also very, very important. We have to take one table and equidistant holes we have to make it. And we should make it a spiral. Take a copper wire and make it a spiral. Then it acts as a solenoid. Just take some iron fillings on the table and jerk it when we switch on. These are arranged like this, inside and outside. Yes. This appears as a bar magnet. Magnetic field lines. These field lines also has same direction, north to south. Where it is north, where it is south. This is very, very important. For example, here the current is going like this. See, current is going like this, like this, like this. It is anti-clockwise. When current is in anti-clockwise, magnetic field is outside. See, I am the right hand rule. When current is upper, magnetic field anti-clockwise. When current is in anti-clockwise, magnetic field upper. So in the same sense, magnetic field this one. So magnetic field is coming out. So if it is coming out, that is the north pole. Already you know. From north, magnetic field lines are coming. It is not. When there is a anti-clockwise current, north pole will form. Other one, south pole. Yes. So this is very important experiment. Very easy once you read very carefully. Next one, force. When I take a copper wire with current, around this magnetic field will form, already you know. When I take external bar magnet or magnet, due to this magnet, some force will act on this wire. Due to that force, it may deflect. That force how much? If it is a charge, QVB sin theta. If it is a current, ILB sin theta. This is called Bill sin theta, but you should write like this one. Don't write Bill sin theta. ILB sin theta, QVB sin theta. Because this theta is between V and B. This theta is between L and B. That's what we should write like that. Yes. So if the magnetic field, if the charge is passing parallel to the magnetic field, no force will act, because parallel means theta should be 0. If the charge is perpendicular in the magnetic field, force will act. If charge is not moving, no force will act, because stationary charges does not have any magnetic field. When charge is passing, moving, then only magnetic field will form. Here also same. So it is very important. The force direction we can find with the help of Fleming left hand rule and right hand rule. This question may ask in the examination. So once I will give one question. See example here. Very simple. Magnetic field into the paper. Into the paper. Inside. Current is going the east. This is a Q charge is going in the east direction. East or right. What is the force acting on force direction?
Upwards.
See here. I am checking. This is a current. Current should be and magnetic field into the paper. This is upward.
Up.
So the force acting in this direction. Very simple. You can use. Yes. Now electric motor. Motor means the device which can convert electrical energy into mechanical energy. Working principle is, it works on the principle of when a current carrying coil kept in uniform magnetic field, it experiences the force. Due to that, it can rotate. The important points here: construction, horseshoe magnets, strong horseshoe magnet. Horseshoe magnet can produce uniform magnetic field. Next, armature. Next, commutators or offerings. Next, carbon brushes. Next, battery switch. Working very simple. When I switch on, the current is passes through B1, C1 to AB and CD, C2, B2. In AB and CD, current directions are opposite. According to left hand rule, AB pushes down, CD pushes up. So it can rotate in anti-clockwise direction. When it rotates 90 degrees, this C2 will go up, C1 will come down, and the current may cut off. But due to inertia of motion, that C2 again come to contact with B1. Then C1 contact with B2. Then again current passing through B1, C2 to DC, BA, like this. So like this, continually will rotate the motor in anti-clockwise direction. Motor rotation depends upon area of armature, number of coils, strength of the magnet, strength of the current. The RPM, rotation per minute, will depend on these factors. So many applications are there. Fan, cooler, mixie, everything rotating because of this magnet and current coil. So this is the first part. In that they are asking why you use that half rings, commutators. Commutators use is, commutators can change the current direction. If there is no change in current direction, the coil will not rotate continuously. Yes. So next yes, now second part. In second part mainly we are discussing about Faraday's law, then Lenz principle, then generators. Very simple. Faraday's law is very important. Experiment is there. Faraday's law also important. This law is called electromagnetic induction. Yes. Now look, see. When there is a continuous magnetic flux change in a coil, it can create some induced current. This phenomenon is called electromagnetic induction or Faraday's law. E is equals to EMF of induced current is equals to N into delta pi by delta T. So now next experiment. Just arrange like this one coil with a galvanometer and magnet. If you move this magnet in front of the copper wire, current will come. Magnetic field will deflect. Even if you take south pole, moving, flux change and current will create. But if magnet is at rest, not moving, no current. Even if coil rotating in front of the magnet, current will produce. You know already in movie, some movie, Maryada Ravana movie is there. In that one bicycle is there, to that one light will come due to this only. There is not a battery. Inside copper wire is there, middle magnet is there, and inside magnet is there, middle copper wire. When copper wire is rotating, current will create. If copper wire and magnet both are moving with the same speed, no current will prepare, no flux will change. So it is experiment and also very important. Next, Lenz principle. Lenz principle explained the direction of induced current. He is saying the induced current direction. So the formula can be like this. E is equals to minus N delta pi by delta T. N is the number of coils, minus is the direction of the current. Induced current direction always opposite to the flux change in the coil, in the flux. It is very important. Opposite. So for example, if you take this is a coil, this is the south pole. If south pole is coming towards the coil, current will create. In which direction current create? Lenz is saying the current can create in clockwise direction. Because south pole is coming. So when it is coming, flux will increase. Current will appear in decreasing flux direction. To decrease, this has to oppose. So when it is south pole, clockwise, south pole will form, south reflector, so repel, that's why it go back. In that condition it can form south. When it takes south pole back up, then here clockwise, anti-clockwise direction, north pole will form. In the same sense, south, the north, you can check it. And also applications of Faraday they are asking in the exam. Yes, Faraday applications, tape recorder, induction stove, security checker, even transformers, ATM card. These are the applications of the Faraday. Electric fan is not application of the Faraday, it is application of motor. Applications are most important. They may ask about induction stove, how it will work. Just read very carefully. They lost about the generators. It is very simple. I am going to it. Generator. Say these are the magnet, north and south. Here armature, A, B and C, D. When I rotated this armature, current can create. So this generator means the device which can convert mechanical energy into electrical energy. And also one more working principle is, it works on the principle of electromagnetic induction. When there is a continuous magnetic flux change, it can create some current, that principle. Here is parts magnet, armature, slip rings. These are called S1, S2. These are carbon brushes B1, B2, and this load resistance RL. Simple, very, very easy. When I rotate it continuously, it can create AC current, alternative current, because slip rings we are using for AC. For DC we have to use commutators. So AC current is, this is the AC current. Very simple working also. If it is, just imagine if it is a coil in like this direction, rotate in this direction, there is no flux change, so current will be 0 here. If rotated in anti-clockwise direction 90 degrees, then current goes to maximum flux. Then again 90 degrees come to 0, again 90 degrees, once again maximum, but it in reverse direction. So this is AC current. AC current frequency in India 50 Hz. If you want to change, instead of slip rings, if you take half inch commutators, the half current will reverse and will come like this. This is the DC current. This frequency is 0 because same line. So in the examination they ask like this. This current is called DC current. Frequency is 0. This is AC current. Frequency is 50 Hz in India. That means in 1 second it can change 100 times. Very easy. So everybody has to learn this chapter. Very, very simple. Very, very easy. Thank you so much all. Go through this final touch. It help you in the examination point of view and the entrance point of view. Thank you so much.